This training video will address the requirements for the proper installation and inspection of conduit. There are many types of conduits used in electrical work on TxDOT projects. A conduit is intended to contain and provide protection for electrical conductors or cables. Item 618 in the latest edition of TxDOT's Standard Specifications book covers specifications for various types of conduits approved for use on TxDOT projects. The installing contractor must furnish conduit from new materials in accordance with Departmental Material Specifications DMS 11030 conduit. The conduit provided on a TxDOT project must also be listed on the Material Producers List, or MPL. The latest edition of the National Electrical Code, or NEC, has specific code articles that cover each type of conduit. Article 344 of the National Electrical Code covers rigid metal conduit. Before conducting any inspection, the inspector is encouraged to review the code articles and the electrical detail standard sheets for each type of conduit commonly used on TxDOT projects. Before inspecting conduit, it is important to remember that the inspector provides important information about work done on the project to the TxDOT engineer. The engineer has the final authority to decide whether the quality of work and materials are acceptable on a TxDOT project. All electrical work must be installed in accordance with the plans for each project. Workmanship and materials must be installed in accordance with the National Electrical Code. However, TxDOT specifications and the NEC do not always agree. TxDOT is the authority having jurisdiction over work done on state right-of-way. Should a conflict arise between the plans and the National Electrical Code, TxDOT specifications take precedence over the NEC. The inspector and the installing contractor must always follow the plans and the engineer's instructions. The correct type of conduit can be determined by consulting the plans for that job. The inspector should confirm that the contractor is installing conduit listed on TxDOT's MPL under Item 618. This can only be accomplished by going in person to the project and comparing the conduit in the field to what is listed on the MPL. Before visiting the project site, the inspector should study and understand the specific job plans, including the electrical detail sheets, the estimate and quantity sheets, as well as the layout sheets. As an example, on the estimate and quantity sheet, notice Item 618. For this project, the contractor will install a 2-inch Schedule 80 PVC conduit and a 2-inch bore, and a 3-inch PVC Schedule 80 conduit in a 3-inch bore. On the illumination layout sheet, notice Item 618 in the conduit chart. This chart specifies 2-inch rigid metallic conduit, RMC, installed in a trench, 2-inch PVC conduit, Schedule 40, installed in a bore, and 2-inch PVC conduit, Schedule 40, installed in a trench. The general notes for this job must also be consulted for any project-specific modifications or revisions to the standard specifications. Notice Item 618 in the general notes. Additionally, the inspector is recommended to review the proposal, any change orders, and all references in the National Electrical Code and the Standard Specifications book. The inspector must take the time to study and learn what the contractor is required to do on the project. When in doubt about what a specific statement means, the inspector should ask the engineer for help. The inspector is always encouraged to ask questions and put forth the effort required to learn the correct way things should be done. Since no one can remember every word of all the job documents, the inspector must bring these documents to the job site and refer to them many times during the inspection. There's a brief checklist at the end of this training video as an aid to the inspector. In addition, the inspector should ensure the following: All conduit installations should be executed in a neat and workmanlike manner. That is, the conduit must be installed straight and securely in place as required by the NEC. Conduit must not be bent or dented in a way that effectively reduces the internal diameter of the conduit. This is determined by passing a foam conduit piston through the conduit. If this cannot be done, then the contractor must make any repairs necessary. Since most of the conduit installed on TxDOT jobs is installed underground, the passing of the piston is a necessary part of the electrical inspection process. The TxDOT Standard Specifications book, under Item 618, Conduit, requires that this be done before any conductors are installed in the conduit. The inspector must ensure that mandrels or properly sized pistons, also known as rats in the electrical industry, are used. The contractor should be encouraged to only use pistons with thick end washers. Damaged pistons may not detect a dent in the conduit and therefore must not be used. When spare or unused conduits are required, they must be capped on both ends according to TxDOT specifications. Duct tape may not be used as a permanent conduit cap. While there are many types of conduits listed in the National Electrical Code, only a few are approved for use on TxDOT jobs. We can begin to understand the differences between the many types of conduits and their uses by separating them into two groups based on the type of material they are made of. First, let us divide all conduits into two large groups, one being metallic and the other being non-metallic. Rigid metal conduit is made of galvanized steel. This type of conduit is also called by its abbreviation RMC. Electrical conduit wall thickness is defined by schedules. Standard wall thickness is classified as Schedule 40, and heavy wall thickness conduit is Schedule 80. RMC is typically Schedule 40. Non-metallic conduits are typically Schedule 40, but Schedule 80 is used when thicker wall conduit is needed. The current edition of ED1 states that all exposed conduits shall be RMC unless otherwise shown on the plans. RMC offers good protection from physical damage. In fact, it is the most durable of all conduits used in electrical work. RMC is galvanized inside and out. It is available in 10-foot sections, and each end is threaded at the factory with a tapered conduit die. RMC can only be bent with the proper conduit bending tools. When installing conduit underground, the raceway must be provided with a minimum of 18 inches of cover. Cover is measured from the top of a raceway, cable, or conductor to the finished grade. When installed under a roadway in a bore, the conduit must have at least 24 inches of cover. Make sure to consult the plans for each job, since many require additional cover. Most of the conduits installed on TxDOT jobs are installed outdoors. The NEC requires that support hardware be suitably protected from corrosion. All hardware, including straps, nuts, bolts, screws, and washers, must be hot-dip galvanized or stainless steel in accordance with DMS 11030 conduit. TxDOT requires above-ground conduits to be secured in place with one-hole, two-hole, or strut-type conduit straps. Two-hole straps or strut-type conduit straps are required when supporting conduits 2 inches in diameter and larger. TxDOT Standard Sheet ED10 requires strut-type mounting hardware on timber poles to be fastened with galvanized or stainless steel lag bolts. The lag bolts must be a minimum of 1.5 inch long and 1/4 inch in diameter. The bolts must be installed with a galvanized flat washer. Other fasteners like sheet metal screws, nails, and smooth shank fasteners are not allowed. The field-cut ends of galvanized strut and field-cut or ungalvanized conduit threads must be coated with a 94% zinc-rich paint as per TxDOT's DMS 8103. This material is available in both brush-on and spray-on applications. Products that meet the spec are listed on the MPL for galvanizing repair paints. Where strut-type mounting hardware is provided, the depth of the gain or notch in a timber pole shall be no more than 5/8 of an inch. The width of the gain shall be no more than 1 7/8 of an inch. All gains should be fashioned in a neat and workmanlike manner. The strut itself may be 1 inch up to 3 3/4 inches in depth. Standard height is 1 7/8 inches. Conduit support spacing requirements from the NEC and TxDOT are not the same. TxDOT conduit support requirements are more stringent than the NEC after the first strap. Both TxDOT and the NEC require that RMC be supported within 3 feet of each end of a conduit body, or junction box. As seen here, the conduits are properly supported. All the conduits have a strap within 3 feet of their termination, as required by TxDOT and the NEC. TxDOT requires RMC conduit to be supported at a maximum distance of 5 feet. The NEC requires that all conduit fittings must be made of the same or similar material as the conduit to which they are connected. All rigid metal conduits must have conduit fittings made of steel or malleable iron, both of which are hot-dipped galvanized. Conduit bodies, such as LBs, are required by TxDOT to be hot-dipped galvanized malleable iron when installed within a run of rigid metal conduit. A die-cast LB can be easily broken by a hammer. A hot-dipped galvanized malleable iron LB fitting can survive a heavier impact. All conduit fittings must be rain-tight. Set screw, zinc die-cast, and pressure cast fittings are not allowed. When electrical conductors exit at the top of a service pole, a weatherhead must be provided. These fittings must be either hot-dipped galvanized malleable iron or sand-cast copper-free aluminum. They are available from many manufacturers. All approved weatherheads must screw on to the threads of the RMC conduit riser. Junction boxes mounted in concrete traffic barriers are specially designed precast polymer concrete boxes, as called for on TxDOT's DMS 11030. All metal junction boxes must be provided with a grounding screw to ground the box. Junction boxes' sizes are specified on the standard sheets when the conductors in the box are sized number 1 AWG through number 8 AWG. Minimum material thickness of sheet metal boxes must comply with the NEC, which is 0.053 inches thick. Junction boxes containing only number 10 to number 12 AWG sizes may be a GRFX as shown here, or a 2-gang cast iron FDC, both made by Appleton or Krauss-Heinz. Surface-mounted junction boxes shall be provided with external mounting feet. All other junction boxes shall be sized in accordance with Table 314.16a of the NEC. When it is necessary to bend conduit, such as rigid metal conduit, special benders must be used. Using a bender with the proper skill ensures that the conduit's internal diameter will not be effectively reduced. All conduits should be cut using the suitable tools. When cut with tools such as hacksaws, they should be cut squarely so the threads cut in the conduit will be full. Even when it is not necessary to thread the ends of a conduit, the ends should still be cut square so fittings may be properly secured to the end of the conduit. When a conduit is cut, the end of the conduit can have a razor-sharp edge. It is important to remove the sharp edge to prevent cutting or nicking of the wire insulation. The process of removing the sharp edge is called reaming. The NEC and TxDOT require that all cut metal conduits be reamed. The NEC does not allow the use of running threads for connection of couplings. When threads are cut into a conduit for an excessively long distance, it may weaken the conduit. Conduits are secured to enclosures with lock nuts, one on the inside and one on the outside. The NEC tells us that lock nuts are rated for conduit support, but not for grounding and bonding. Therefore, TxDOT requires that all metal conduits be provided with a properly installed grounding bushing at the ends of the conduit. The bushing has a lug for attaching a short electrical conductor called a bonding jumper. Grounding bushings have a rounded edge on the inside to minimize the risk of abrasion or damage to the conductor's insulation. Expansion joints provide a place for thermally induced expansion and contraction of conduits to occur. TxDOT requires an expansion joint conduit fitting on all structure-mounted conduits at the end of the structure's expansion joints to allow for movement of the conduit. The installing contractor must also install expansion joint fittings on all continuous runs of exposed conduit mounted externally on structures, such as bridges, at maximum intervals of 150 feet. When inspecting an expansion joint, care should be taken to confirm that the joint has been installed wrench tight. Loose expansion joints allow water to enter the conduit. An expansion joint must allow movement of the conduit. It is not uncommon to see an expansion joint incorrectly installed at one end or the other of its stroke. Some expansion joints have an internal bonding jumper, while others have an external bonding jumper. The materials used in the expansion joint must comply with DMS 11030 conduit. When inspecting an expansion joint on a cold winter day, the expansion joint should be close to the end of its longest expansion. The conduit should be close to coming completely out of the expansion joint. The reverse would be true during a hot summer afternoon. On a hot day, the conduit should be very near the top point or end of the conduit's travel inside the expansion joint. In other words, hot summer, maximum penetration. Cold winter, minimum penetration. TxDOT specifies the types of support for conduits on bridges on ED2. The second major type of conduits is the non-metallic. You are likely familiar with white plastic water and drain piping made of PVC, which stands for polyvinyl chloride. Electrical conduit is also made with PVC. While the two pipes may look similar, except for one being white and the other gray, they are not interchangeable. TxDOT allows rigid nonmetallic PVC conduit to be used underground or embedded in concrete when called for by the plans. PVC conduit is commonly available in Schedule 40 and Schedule 80, with Schedule 40 being the most used conduit on TxDOT projects. The NEC does not allow PVC conduit to be used where it may be subject to physical damage. All conduit must be UL listed and marked appropriately. All PVC manufacturers and their approved model numbers must be listed on the Material Producers List when used on a TxDOT project. When spare or unused conduits are required, they must be capped on both ends per TxDOT specifications. Only approved plastic caps and plugs can be used as permanent conduit caps. Duct tape may not be used as a permanent conduit cap. The ends of all PVC conduits must be cut square. The NEC requires that both the inside and outside of the conduit be reamed to remove rough edges. Proper assembly of PVC conduit involves chemically welding the conduit ends to a conduit coupling or connector. This is done by properly cleaning the joint, priming it with primer, and then applying a coat of solvent cement to each surface. The surfaces can then be mated together, rotating them approximately 1/4 of a turn. Fittings for all types and sizes of PVC electrical conduit must be made of the same type of material as the conduit itself. Only gray-color PVC conduit fittings are allowed in PVC conduit runs. The ends of the PVC conduit runs must be fitted with a bushing or bell end fitting with a rounded edge or connected to a box with a PVC connector and bushing. This requirement helps reduce abrasion and damage to the conductors installed in the conduit. In runs of PVC conduit that terminate in ground boxes or pole bases, TxDOT allows PVC elbows to be used unless otherwise noted in the project's plans. Unlike metal conduits that are bent with physical force, PVC conduit cannot be bent with force alone. PVC conduit is bent in the field using heating equipment until it becomes pliable. After the PVC is softened by heat, it can be bent and formed by hand to the desired shape. PVC must not be exposed to temperatures above its service temperature. While PVC may be heated with many different sources of thermal energy, it can be difficult to judge when too much heat is being applied. Open flame torches can easily produce temperatures above 1800 degrees Fahrenheit. This high temperature can damage PVC conduit. Bleached out white spots on the conduit are common evidence of overheating. In case of extreme overheating, there will be black spots from burning the conduit. All conduits installed underground must be sealed as approved by the engineer. Spray foam sealant and duct seal are two methods that, when properly selected and applied, give good service. Silicone caulk shall not be used to seal conduit ends. The following is a list of important items to check when inspecting conduit systems. This listing is not complete or exhaustive, but is intended as an aid to personnel who may be new to electrical inspections. Has the proper type of conduit been used in each location? Has a grounding bushing been placed on the end of every metal conduit installed on the project? Has a bushing or bell end fitting been placed on the end of every PVC conduit installed on the project? Have all conduits been cleaned of all foreign materials prior to the installation of conductors and cables?